The elements in the compounds bond with a fixed ratio. It means that in water, there are always one oxygen atom and two hydrogen atoms. In the formation of sodium chloride, one sodium atom always combines with one chlorine atom. The change in the type and amount of atoms will make a new compound. For example, in each compound of carbon dioxide, one carbon atom bonds with two oxygen atoms. The combining ratio of carbon and oxygen is 1:2. If we reduce oxygen to 1, it will result in carbon monoxide. It is a highly poisonous compound. Figure 6.4 compounds having different number of similar atoms. Compounds cannot be separated into their constituent elements by simple physical methods. Heat can melt the ice cubes and may turn liquid into vapors, but hydrogen and oxygen will not get apart. In the same way, physical force or pressure can ground rock salt to a fine powder, but it cannot get separated as sodium and chlorine. Formation of compounds. Many of the compounds exist naturally. Many others can be made in the laboratories, through various processes. Chemical changes give rise to new compounds. Some of them are as follows. Burning of sugar. The chemical name of table sugar is sucrose. Upon heating, it combines with oxygen from air and breaks down into water and carbon dioxide. Experiment 1. Materials required: table sugar, Bunsen burner, test tube, matchstick. Procedure: add a few crystals of table sugar into test tube. Heat the test tube at low flame. Observations: white sugar crystals will melt into chocolate brown hard shiny liquid. It is caramel. Result: burning of sugar result in carbon dioxide, water and solid carbon, which is seen as black residue. Summarize the process in an equation. Write the whole procedure into an equation. Sugar molecule joins with atmospheric oxygen at high temperature and gives carbon dioxide and water. During the whole procedure, excess water eliminates out. Write all the components that reacted at left side, separated by a plus sign, such as sugar plus oxygen plus heat. Write all new products formed at right side of arrow, each separated by a plus sign. Sugar plus oxygen plus heat, carbon dioxide plus water plus solid carbon. It is called word equation. A word equation tells us about the whole reaction in minimum words. 2. Burning of magnesium in air. Magnesium is an element. Its symbol is Mg. When it burns in the open air, it joins with oxygen, giving rise to a new compound called magnesium oxide. Magnesium oxide has one magnesium atom and one oxygen atom. Experiment 2. Materials required: magnesium wool, petri dish, wire gauze, tripod stand, matchstick. Procedure: put 1 gram magnesium wool in petri dish. Set the heating system, i.e., wire gauze, on the tripod stand. Burn matchstick and introduce the magnesium wool to the direct flame. Observations: what did you observe? Result: magnesium element reacts with atmospheric oxygen and forms a new compound known as magnesium oxide. Word equation: magnesium plus oxygen plus heat, magnesium oxide. 3. Formation of iron sulfide. Another new compound, iron sulfide, can be prepared by heating iron and sulfur. Experiment with 3 materials: iron fillings, sulfur, china dish, wire gauze, Bunsen burner, matchbox, stirrer. Procedure: place 1 to 2 grams iron fillings into the china dish. Set the heating system. Place the china dish at the gauze. Turn on the flame. Slowly add sulfur onto the fillings. Keep stirring the filling to avoid stickiness. Observations: what did you observe? Result: iron reacts with sulfur, giving rise to a new compound known as iron sulfide. Word equation: write the word equation for this reaction. Skill 6.5 Illustrate the formation of a compound with the help of a word equation. Illustration. SS. Critical thinking, scientific literacy. Objective: to illustrate formation of compound using a word equation that will help to represent chemical reactions in a clear and descriptive way, enhancing their understanding of chemical processes. Instructions: scan the QR code to access the worksheet and solve it. Homework 3. Search and draw the structure arrangement of particles of the atoms in above-mentioned compounds.